Hello everyone. My name is Guruprasad K N, Assistant Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysuru. Today I will be demonstrating how to design a common source MOSFET amplifier using Multisim. So the aim of this experiment is to design and study a common source MOSFET amplifier using Multisim and determine its frequency response. And the objective is to analyze the voltage gain characteristics of this MOSFET amplifier through multisim, and we will observe how the gain varies at low, mid and high frequencies. So this is the circuit diagram which we will be implementing using Multisim software. So in the circuit diagram we have a FET. I have chosen 2N7000 R1, R2, RD, RS, 4 resistors of different values, 2 coupling capacitors C1 and C2 and 1 bypass capacitor. And also I have chosen one AC signal source for the input signal and CRO, and to observe the frequency response I have chosen a Bode plotter. So our output and input waveforms will be observed at the end, which will be looking similar to like this, and we will also observe frequency response using Bode plotter, and we will tabulate the readings from the graph. Now let me start. So first let me choose a MOSFET 2N7000 and the resistors and I also need capacitor and I need power supply. So I will take VDD. I also require ground terminal. So let me take all the components which I require to do this experiment. I require signal voltage source. So let me drag and drop here. So total I need 4 resistors. So I will rotate this one. So I will copy paste the values. So R1 value is 2 mega ohms. Let me change the value. R2 value I have chosen 1 mega ohm. Then R3 value, or I call it as RD, the value is 2.5 kilo. So let me change the label to RD. Then source resistance, let me call it as RS, and the value is 2.5 kilo. Then this capacitor value I am choosing 0.002 microfarads, and I need one more coupling capacitor whose value is 0.636 microfarads, and also I require another bypass capacitor whose value I will be choosing as 6.3 396 microfarads. So now let me connect this circuit. So before that one, let me change VDD value to 15. So now I'm doing all the connections. Now I am connecting R2 to this junction. Then connect other terminal of resistor R2 to the ground. Then I am connecting source resistance RS. Then the bypass capacitor C3. Now let me connect this junction to the capacitor and input voltage. Since I am doing amplifier, let me take input voltage in terms of millivolts. So I will choose 100 milli. Let the frequency be 1 kilohertz. Now let me choose the output device, oscilloscope. I also require a ground terminal to connect the negative terminals of oscilloscope. So let me connect the output to channel B. Now the channel A is connected to input. So let me change the color so that it will be easy for me to differentiate between input and output. So I will change the input to the blue color. And to check the frequency response, I require Bode plotter. I will pick the Bode plotter. Here also I require a ground terminal to connect the negative pins. So I am connecting all negative to the ground. Output is connected to the same pin and the input is connected to input terminal. So this will complete the circuit diagram of common source MOSFET amplifier. So let us verify once again if there any value is changed or something like that. No, everything is perfect. So let me run the circuit and double click on this one. So I am setting it to 1 milliseconds. Now channel A is input. So input will be in terms of milliamperes. So let me set it to milliamperes. So I am taking 100 milliamperes. And the output, let me choose in terms of volts. Let me increase this one so that it is visible. So blue color is input, that is channel A. So I am taking it upside. Red color is output, so I am bringing it down. So what we can see here is the blue color is input, which is 100 millivolts, very small, whereas the red color is output, which is amplified version. So let me check what are the input and output values. So I can drag this bar and we can check here. The input is around 97.9 millivolts, that is very small. So I have given 100 millivolts here. Approximately I am getting 97 or 98 millivolts as the input. And if I see the output I am getting in channel B 2.48 volts. So the input is 98 millivolts, the output is 2.48 volts. So input in terms of millivolts, output will be in terms of volts. So definitely we can see there is amplification. So a smaller value is amplified into a larger value. And also one thing you can see, the input and output waveforms have the phase shift of 180 degree between them. So the blue color is input, red color is output, and we can see there is a phase shift of 180 degree between input and output waveform. We are observing the output through collector terminal. Now let me go to the Bode plotter. So double click on this Bode plot. So make some changes here. Let me set frequency to 100 megahertz maximum value and the increment of 20 hertz, and let me take this F, set it to 40 dB and this one to 0. Then let me reverse it. So we can clearly see here we have got frequency response curve. So what we can observe from this one is x-axis is frequency, y-axis is gain. As the frequency increases, gain will also change. So initially, as the frequency is increased, gain will increase. Later, at mid-band frequency, the gain will become constant, and at higher frequencies, gain will decrease. Now, let me find out. As an example, I will take, for example, see here at 230 Hertz, the gain is 27.72 dB. Similarly, at 429 Hertz, the gain is 28.656 dB. Now let me check what is the maximum value of gain. So the maximum gain is here 31 dB. So this should be noted in the graph. So the maximum gain is 31 dB. Now I have to find out 3 dB bandwidth, 3 dB bandwidth. For that one, I have to find out what is the 3 dB gain. So the maximum value of gain is 31 dB. Now I have to find out at what point 28 dB will come. So 31 minus 3, that is 28. So approximately 429 Hertz. So the value where the gain is 28 dB or approximately 28 dB, I have to choose that frequency. That frequency is F1, lower cutoff frequency. So approximately I would write 429. So before that one, 3 dB one is 28 dB. I have to minus 3. 31 minus 3 is 28. And this one is 429 Hertz. Now on the other side also I have to check where I will going to get 28 dB. Somewhere here I am getting 28 dB. The frequency is 2.9 megahertz approximately. So 2.9 megahertz. So lower cutoff frequency 429 hertz, upper cutoff frequency 2.9 megahertz, and if you take the difference between those two, that will be bandwidth. So this is how we are going to calculate the bandwidth in MOSFET amplifier. Thank you for watching.